We're going to talk a little bit to kind of wrap up this first unit on parent functions. So parent functions are the most basic version of functions that we are going to study throughout this year. And as we're working on this, I want you to be thinking about what are some ways that we can identify which function family an equation belongs to. And I'll show you some things to watch out for. So we have 6 of them. There's 6 boxes here. And the first one is the most basic. It's one you probably studied a lot in Algebra 1. Linear. And a linear function is y equals x. It has lots of important ordered pairs: 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 5, negative 5, negative 6, negative 6, negative 7, negative 7. That line is the parent function for linear. So we can recognize when things are lines because of how their graph looks, or because we will see just x without any exponents or anything added on to them. The next one that we'll study this year is absolute value. So that comes up later. And the equation for absolute value, you've actually seen a little bit if you've done the Desmos that we had. Y equals the absolute value of x, right? It's a little jail. We can think of absolute value as MIPIT. Which means make it positive. So we take a number for x, and absolute value makes it positive. So, for example, there's an ordered pair at 0, 0. And on the right-hand side, all the x values are positive. So we kind of just follow up. But on the left-hand side, negative 1, MIPIT, turn it to positive 1. Negative 2, MIPIT, turn it to positive 2. So negative 3, 3 is an ordered pair we have. Or negative 4, 4. Or negative 5, 5. Or negative 6, 6. The x was negative, but when we MIPIT, it turns back positive. And we get this kind of flying V shape. Right? We looked at that a little bit when we did our Desmos activity. We started doing absolute value. We will know it's absolute value because we will have kind of those 2 bars around our x. Our next one, quadratic. The graph of a quadratic is what's called a parabola. It's a U-shaped graph that represents y equals x squared. So we will know it's quadratic because we will see a squared in the equation. Okay. Our graph has some key points: 0, 0, 1, 1, but 2 squared is 4, and 3 squared is 9. If I go the other way, negative 2 squared is a positive 4. Negative 3 squared is a positive 9. So we need to be mindful of how that gives us our U-shaped parabola to make our quadratic equation. After we do a lot with quadratics this year, we will go to cubics. A cubic equation is represented with x to the third. So when we see that little 3, that tells us we are working with a cubic. X cubed is the language that we use. Okay? So the cubic graph has a point at 0, 0. It has a point at 1, 1. It has a point at 2, 8. And that's about as far as we're going to get. When we go into the negatives, -1, -1, and -2, -8. We get kind of an S curve. So when you see this S curve, that's how we know something is cubic. 2 left. We're doing great. After we study cubics, we will go to square roots. Square root graphs are pretty awesome, but they have some unique rules. So the equation is y equals root or square root of x. The only rule is that x has to be greater than or equal to 0. We can only put 0 or positive numbers underneath it. And some key points for our graph would be 0, 0, 1, 1, 4, 2, and 9, 3. I'm going to go way out there. Notice this graph starts at 0, 0, and it will not go into the negatives because we cannot do negatives under our square root. The sixth and final graph is rational, and it is formed by y equals 1 over x. Because we are dividing, we have to account for a special rule. X cannot be 0. AKA, the denominator cannot be 0 because we cannot divide by 0. All that to say, when we do the graph, we're going to have some interesting things happen at 0. But first, let's get one side of our graph drawn. So if my x value is 2, my y value becomes 1 over 2. And if my x value is 1/2, my y value becomes 2. So we do a lot of reciprocals here. So we can kind of think of this as being a reciprocal as we work through this. But the shape of this graph looks like this. Whoa, there we go. And then we always want to, well, not always, because we didn't for the square root, but in this case, we want to acknowledge what happens on the negative side of the graph. And what you'll notice is we get a shape that looks like this. Because we cannot be 0, we're going to end up with what's called an asymptote. We'll end up with what's called an asymptote at 0. So that's what's happening, and we can't be 0, so we get this kind of imaginary line at 0. To shut down our notes, or to wrap them up, I just want to run through a couple steps with you. We're going to do some transformations on these parent functions. So to identify a transformation, here's what we're going to do. First, we're going to open Desmos. It's going to be our helpful tool. After we open Desmos, we're going to graph two things. The first thing we're going to graph is the parent function graphed first. So we type in the parent function. And then we graph the problem function. And then we can compare how did we go from the parent to the new. Okay, so that's something just to be mindful